Hello everyone. Today we are going to talk about the tutorial of process optimization. Process optimization is related to operation system. So we are going to solve 5 example of linear programming with graphical method, linear programming with simplex method, transportation method, decision making, and paired CMP, which is scheduling, related to scheduling. Okay, without wasting any time, we move to the first example. Okay, solve the problem, which is the maximization of z equal to 10x1 plus 20x2 subjected to minus x1 plus 2x2 less than 15. We have an x1 plus x2 less than 13, and we have 5x1 plus 3x2 less than 45, and obviously each x should be bigger than or equal than 0. So we have 4 limitation and one objective function, which is z equal to 10x plus 2 x2 to solve it. Okay, so how to solve it? I open a new. Okay, so we have this function that is maximization, which is maximization z equal to 10 x1 plus 20 x2, which is, I open here, okay, which is subject to minus x1 plus x2 less than 15, x1 plus x2 less than 12, 5x1 plus 3x2 less than 45, and x1 was bigger than 0. Okay, first of all we have to make we have two design variables, x1 and x2. So what we thought we have to use? We have to use graphical method, because we have two variables, which is x1 and x2 are our variables. Okay, first we have to change inequality to equality. What we have to do, we have to make a graph, right? So in that case I will make one graph here, one graph here, okay, which is over axis is x axis and y axis, x1 and x2. Okay, so we are going to find the feasible area. So first equation, we have a minus x plus 2x2 less than 15, which is we're going to draw it, so we can make it equal to 15. Equal to 15. So we are going to draw it, so we're supposed to have 2 points, which is x1 equal to 0, as we assume x1 equal to 0 and x1 x2 equal to 0. So if we have 2 points, we can draw the linear line. So when x1 equal to 0, 2 x2 equal to 15. What is x2? Is 7.5. So the first point is 0 and 7.5. Okay, so for x2 we have, if x2 equal to 0, we have minus x1 equal to 15. So x1 equal to minus 15. So we have minus 15 and 0. This is one point, this is another point. Okay, for the next equation we have x1 plus x2 equal to 12. So x1 equal to 0, x2 equal to 12. If x2 equal to 0, x1 equal to 12. So we'll have one point which is 0 and 12, another one is 12 and 0. So third line we have 5x1 plus 3x2 equal to 45. Actually less than, but we want to draw it, we put equal to make it easier. If x1 equal to 0, we have 3x2 equal to 45. So x2 equal to 15. So we have 0 and 15. So if x2 equal to 0, we have x2 equal to 0, we have 5x1 equal to 45. So x1 equal to 9. So we have 9 and 0. Okay, we have all the, so of course if x1 equal to 0, x2 equals. Okay, so we list all the points that we find out. So all the points is, okay, 0 for the first line. We have 0 and 7.5, 0 and 7.5. Let's say for example 1 2 3 4 5 6 7 8, somewhere here. Another one is minus 15 and 0. So minus 15 cannot make. I have to draw again. I make draw it better. So 1 2 3 4 5 6 7 8. Still we have to make it a bigger one, down better. Okay, make a bigger one. One, two, three, 4, 5, 6, 7, 8. Okay. It should be vertically easier. Somewhere here. 12, 13, 14. Okay, minus 15, this is minus 15 and 0, this is 7.5 and 0. Okay, choose another color, which is this line. This will be our line. So which is minus x1 which is minus x1 plus 2x2 less than 15. Less than 15. Okay. So because we know it's a less, so for example, if less, the feasible area will be below it, right? This is less than 50. For example, this point 0 and 0 and 0 is less than 15, right? So it will be below it. Okay, another one, for another point we have 0, 15. 0 is x1, 0, and we have here 0 and 15, 9 and 0. In 8, 9, 10, 11, 12, 13, 14, 15 here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, which is here. So I make it with this color. It's difficult. I make it with this color, which is this line. Okay, this line is also this line is this one, this line, minus 5x1 plus 3x2 less than 45. So less than 45 will be this. For example, 0 and 0 is less than. So we have so far this area. We know x1 and x2 is bigger than 0, right? We know from the limitation provided in here. Okay, so another points that we lost is 12, 0, 12 and 12, 0. We found it, which is 10, 11, 12. Let's say 12 is here, and 12 is 8, 9, 10, 8, 9, 10, 11, 12, which is 0 here. Which is this line. Okay, which is less also. Okay, so here will be our in feasible area, intersection of all the feasible area. Okay, for this we have to find on the edge, the corners. We use corner points. How many corners we have? 1, 2, 3, 4, 5. So this point we know, 0 and 0. This point we know, which is 9 and 0. This point is 0 and 7.5. This point and this point we don't have any idea. Okay, how to find these 2 points, the 2 corners? We have 2 lines. We have 2 lines which are connected to leave me alone. Okay, we have 2 lines that we are going to find the intersection. How to find the intersection? We have to make them equal. Okay, I forgot to put the line. This is x1 plus x2. The equation is less than 12. Okay, this line, see x1 plus x2, for example this line, and what's the equation of this? This is the equation of this. Mistake. Made a mistake. Made a mistake. Made a mistake. Okay, this is x1 plus x2 less than 12. Okay, so these two lines be equal together. So x3 5x1 plus 3x2 equal to 15. Another line is x1 plus x2 x1 plus x2 equal to 12. Okay, so from this we know that x1 is equal to 12 minus x2. So what we have to do? We have to substitute this equation inside the first equation. So become 5 12 minus x2 plus 3x2 equal to 45. Okay, so this will be 60 minus 5x2 plus 3x2 x2 equal to 45. 60 become minus 15. This one become minus 2x2. So x2 equal to 7.5. So if x2 is equal to 7.5, so we have x1 equal to 12 minus 7.5, which is 4.5. So the point that we are looking for is 7.5 and 4.5. 7.5 and 4.5. Okay, then next point, will be intersection of this line and this line. So one equation, I write the equation of the two lines that they intersected, which is x1 plus x2 equal to 12 and minus x1 plus 2x2 equal to 15. So again we have x1 equal to 12 minus x2, then substitute inside here. So minus 12 minus x1, close the bracket, plus 2 x2 equal to 15. So we have to find this is x2. Okay, so 12 would then become 3 here. No, become 27. Sorry, 27. Here will be plus become 3x2. x2 equal to 9. If x2 equal to 9, from here x1 equal to 12 minus 9 from here, which is 3. So the point is 3 and 9. Go back here to the over 7, which is this point 3 and 9. So we list down all the, I open a new, list down all the points. So one point is 0 and 0, 0 and 7.5, 0 0 0 7.5, 9 9 and 0, 3 and 9, 4.5 and 7.5. Oh, here I made a mistake. 7.5 and 4.5 and 7.5. Right. 4.5 and 7.5. My scale is not true, so it's, when I was drawing, then it's not accurate actually. But from our equation we found this, okay? So for each, now what should I do? For each I have to calculate the z. So what is z actually? Z was 10x1 plus 20x2. So x2. Okay, if I put 0 and 0, z becomes 0. Okay, z will be, for 7.5 become 20 times 7.5, right? Will be 150 0. 9 and 0, z will be what? 90. For this, z will be 3 times 9, 3 times 10 become 30, 9 times 20 become 180, become 210. And for the last one will be z equal to 3 times 10 times become 45 plus 20 times 150 will be 195. Okay, go back to our question. Here question was maximization, right? Maximization. If it is maximization, we have to look for the corner point that have the maximum value. So we have to write the answer is x1 equal to 3, x2 equal to 9, and the maximum value is 210. Z equal 210. Okay, that's the answer. Maybe in the question they will ask for validation. For validation, what we shall have to do? Now we know the answer. We have to go back to our question. Okay, answer is 3 and 9, right? So we are going to validate. Okay, see, look at the first one, first limitation, that we have minus 3, for example, if I substitute inside, plus 2 times 9. 2 times 9 is 18. Minus 3 become 15. Is it less than 15? Yes. True. Next one. 3 plus 9 less than 12. Yes. Because 12 is equal. It's true. Right? Last one. 5 times 3 become 45 for the last one. 9 times 3 become 27. 27 plus 45. 45 plus 27 become this one 15. 15 plus 27 is 42. So is 42 less than 45? Yes. Each of them also bigger than 0. So it's validated. This is validation. Okay. Okay. Let's go to the second question. Okay. So this first one done. The second one, linear with simplex method. Okay. Question number 2. So we have again maximization is similar. Maximization, and we have this, actually this limitation subjected to 3x1 plus 3x3 less than 120 and this 3. Okay, again maximization. We go back to our note, open a new. This is for question 2. So in question 2 we have 3 parameters. If we have 3 parameters, what's the 3 parameters? What are the 3 parameters? Are minus x1, which is maximization, x1 plus 2x2 plus x3. Okay. So we have 3 desired variables, which is x1, x2, x3, which are our design variables. Okay, these are variables, and we have 3 limitation, which is x1 plus x3 less than 1 to 0, x1 minus x2 minus 4x3 less than 8t minus 3x1 plus x2 plus 2x3 is less than 100, and x1 and x2 bigger than 0. Okay, first of all, we have to change inequality to equality. So what we have to we have to add a slack variable. Okay, we have three equations of limitation. Okay, here three. For each we have to add one slack value, which is S1, S2 and S3. This is a list of our slack value. Okay, so how to use it, how to change is like this. We write down the equation again, x3, I add s1 in here, then equal to 1 to 0. It's changed to equality. Okay, for the second one, x1 minus x2 minus 4x3 plus s2 is equal to 80. The last one is minus 3x1 plus x2 plus 2x3 plus s3 equal to 100. Okay, already changed to equality. For the z, I write it here better. We change it to, we shift all of right side to the left side. So z will be equal to z plus x1 minus 2x2 minus x3 equal to 0. Okay, now we have to make a table for the simplex, table of the coefficient. So what we have to have in our table, we're supposed to have this. Our table, we have z s1 s2 s3. Okay, so we will have z x1 x2 x3 s1 s2 s3 are the right side and the ratio. No space again. x1 x2 x3 s1 s2 s3 right side and ratio. Okay, so what we do, we write down all the coefficient. Okay, so for z is in first equation, second, third, fourth. For the first equation we have 1 z1. How was the coefficient of x1? 1. Coefficient of x2 minus 2. Coefficient of x3 minus 1. S is 0 0 0 and right side is 0. Okay, for the second equation for z we have 0. For x1 we have 3. x2 we don't have. x3 we have 1. slack 1 we have 1 0 0 and the right side is this one 0 1 2 0. Okay, ratio letter. 0 for second equation, for the second or for the third equation we have 1 minus 1 minus 4 0 1 0 80. For the fourth equation we have this one, sorry, the last equation, this one, we have minus 3 1 2 0 0 1 and 100. First, iteration 0 already done. Okay, it's complete. Now we have to find the pivot value. To find the pivot value, we have to look on the Z row. In the Z row, which one is the biggest maximum, biggest minus is minus 2. So this is my pivot row. Okay, so I look at S1, S2, S3. In the pivot I have 1 0 minus 1 and 1. So first condition supposed to be non-zero, non-negative, absolute positive. Which one is absolute positive? Only this. So I can calculate the ratio, which is 100 over 1. So because I have one positive, this one is maximum, right? I don't have other to compare. If I had another one, I should compare. So this line also selected as my pivot. Okay, Z S1 S2, don't forget to change S3 to X2. Why? Because pivot selected from X2 column. Okay, first I have to make the pivot row, this one, pivot value to 1. Because this is 1, there is no change. We just write it down. Otherwise, be all of them divided to 1, divided to 1, divided to 1, divided to 1. Okay, so because divided to 1, what is 1? The pivot value. Because 1 is any number divided to 1 become itself, so no change. What's our job after this? To make upside of this 0. Okay, we have to make the top side 0. Okay, top side 0. How to do that? We have to make so we look at this column Z and this pivot column. So we had one equation for that the new R equal to the previous R, the pivot value, times new R of the pivot row. Okay, so how does it work? Is work like this. You write down all the pivot value, which is 1 minus 1 minus 1 1 minus 2 minus 1 0 0 0. Write it down. 1 minus 2 minus 1 0 0 0. So what is P in that case? Over P is minus 2. Write it down. Minus 2 minus 2 minus 2 minus 2 minus 2 minus 2. What is new pivot row we can see here, minus 3 1 2 0 0 1 100. Okay, minus 3 1 2 minus 3 minus 3 1 2 0 0 1 0 0 1. We forgot one of them. Right, I forgot actually. Minus 2 100. Okay, so now we calculate. This one become 1 minus 1 minus 6 become minus 5. This will be 2. This becomes 0. Supposed to be 0, right? Supposed to be 0, as I mentioned. Okay, this will be minus 1 plus 4 will be minus will be 3. This one becomes 0 0 2 200. Okay, so we write it down. Minus 5 0 3 3 0 0 0 0 2 200. Okay, for the next one same procedure. So 3 0 1 1 0 0 1 2, because it's already 0, so we just only write it down. Okay, 3 1 1 0 0 1 2 0. The last one will be this, right? So what's the pivot value? Minus 1, right? Minus 1. Okay, I write it down, all the parameters in here, which is all the row 1 minus 1 minus 4 0 1 and 0. Okay, write it down. Minus 1 minus 1, right? Minus 1 or 1? Which is 1, which is 1 minus 1 minus 4 0 1 0 80 minus, what is our pivot value for this row? Is in the pivot column, minus 1. Okay, for all bracket minus 1 minus 1 minus 1 minus 1 minus 1 minus 1 minus 1. So write down the pivot, new pivot, minus 3 1 2 0 0 1 100 2. Okay, This is 18, not 8. This one 0. So this will be 1 plus 3, sorry, minus 3 minus 2. This will be 0. This will be minus 4 minus 2, which is, sorry, plus 2 become minus 2. This one will be 0. This one will be 0. This will be 1. This will be 1. This will be 180, right? So we write down here minus 2, 0, minus 2, 0, 1, 180. Okay, complete. Iteration number 1. Okay, look at the z. Do we have minus? Yes, we have minus. We have minus. Okay. So which one the maximum minus? Only this, right? So this is our pivot. Now what we have to do, look at each pivot row. Which of them are positive? This one. Look, find the positive. Okay. What's the ratio? 12 over 3, which is 60. Okay. 120 over 3 will be 60. Because we have only one positive, so it's automatically the maximum is this one. So this time our pivot row is here, and 3 is our pivot value. Okay, what we have to do, in the next iteration, we have to write down again z parameters. S2 should convert it to x1, connected to x1, right? x1, S2, x2. One, 0, 0, 0. Okay. Which one is the pivot? This one. It should be 1, 0, 1 over 3. All of them should be over the pivot value 0, 0, 60. Oh, this one 40. Sorry, 40. Okay. The rest should be 0. How to make 0? Again, we have to apply the same procedure with these. So what's the pivot value for z? Minus 5. Okay, minus 5, we write down minus 5, 0, 3, 0, 0, 2, 200. Minus what? Minus the pivot value of this column, which is minus 5. Okay, in the bracket. Minus 5, minus 5, minus 5, minus 5, minus 5, minus 5, minus 5. What's the new pivot value? Is this one, 0, new pivot value. 1, 0, 1/3, 1/3, 0, 0, 40. So equal to 0, 5. Sorry. This one also 0. Becomes 0. This will be 3 plus 5/3 will be 3914/3. This will be 5/3. This will be 0. This will be 2. This will be 200 plus 200 becomes 400. So I write here 0, here 0, 0, 14/3, 5/3, 0, 2, 400. Okay, next one, which is this. Okay, I write down all the row of these: -2, 0, -2, okay, -2, 0, -2, 1, 1, 1, 1, 8, 0. Minus what? Minus the pivot value of this column, which is -2. Bracket -2, bracket -2, bracket -2, bracket -2, bracket -2, bracket -2, bracket -2. Okay, which times to what? The new pivot one, which is this, which is 0, 1, which is 0, 1, 1/3, 1/3, 0, 0, and 40. Which will be first one is -2. -2. First value is 1, which is 0, 0, -2 plus 2/3 will be -4/3. -4/3 will be 1 plus 2/3 will be 5/3. 5/3, 4/3, become 1, become 260, right? 18 plus 180 plus 80 from 260. Okay, write it down. Which is 0 minus 4 3 5 over 3 1 1 2 6 0. The last one and the most important one is the last one and the most important one, which is here, minus 3 minus 3 1 2 0 0 minus 3 1 2 0 0 1 and 100 minus what? Minus 2. Why? Because minus 3, sorry, minus 3, the pivot is minus 3 here. Minus 3 minus 3. So which is 0, sorry, 1 0 1 over 3 0 0 0 40. What are they? Is a new pivot value in our this row, which is the new value for the previous iteration pivot, which is here. Okay, so if we calculate, it will be 0 will be 1 0 0 1 2 minus 1 become 3. This one 0, this one 0, this one 0, no, sorry, this one 1, this one 100 plus 120 become 220. Okay, write it down. Write it down here in the table, the calculator value, which is 0 1 3 1 0 1 2 2 0. Okay, how to find the answer? Look at this. Look at this. Look at this. This two. X1 equal to what? Right side 40. X1 equal to what? X2 equal to what? Right side 220. This is our answer. But we don't know what is x3. How to find x3? How to find x3? Okay, from this we know 40 is our maximum value. Maximum value is a maximum value. In our z, we have the equation, right? We have the equation which is minus x plus 2x2 plus x3. We substitute x1 and x2 equal to 400. We can get that x3 equal to x3 equal to x2 we can find out minus 40 plus 2 times 4 plus x3 equal to 400. X3 is equal to 0. So our answer is the answer is x1 equal to 40, x2 equal to 220, x3 equal to 0, and the maximum value is 400. Z equal to 400. Done. The next problem is transportation problem. Is the transportation problem? I don't have the answer here. I have answer here. Okay. And the next one is the transportation problem.